Okay, you may want to grab your table.
Russell, grab our table, come on.
Okay. Now, do what?
He said grab our table.
Periodic table.
I'm not even kidding. I said.
Okay. So the
I'm not even doing
the host. Okay. The host in this video. The host in this video and narrator at the same time.
Why are people taking my attention? Shut up.
So, moving forward, the host and the narrator in this video keeps going forward and says, gold, element 79. So even if he didn't say gold, why is 79 so important?
That's the way we recognize it.
That's how many.
Say that again.
Is it the atomic?
That's the atomic number. Then, when he wanted to go to the stock exchange, okay, that still takes place. They still will trade gold, silver, copper, other types of goods all across the world, okay? Then when he's talking about copper to, I want to say it was a lady, I don't know if she was a stockbroker, but had something to do with the stock market. So he goes on and says, copper, element 29, 29 protons, 29 electrons. Yes?
I kind of have a dumb question. So you know how like gold is 79? Could that be moved to like a different part on the table, but it'd still be like the same thing, right?
No, it cannot.
And,
It's
like,
that is the only place gold makes sense with its properties.
So
Okay.
is it just put there and then it's a given the number, or is it already like?
No, because okay, so when you go one box to the right, you're no longer talking about gold because now it has one more proton. And that proton going from 79 to 80 is what we went through yesterday, which is which element? Number 80. Mercury. So every time you increase that increment of 1, you're changing the element. And you cannot have 80 protons in a nucleus and be talking about gold. It can only be mercury. Yes?
So about like finding the electrons and protons and neutrons or whatever. So if there's a way we can find them, is there like a reason that they're not already like in the box, like we never saw it?
Because it's what you're given enough information to calculate that. Okay? Because just for convenience sake, they're just on a periodic table on the wall, that might be fine. But a periodic table as a paper in front of you, it just gets to be more so inconvenient the more information that is. It's not that it's useless. It's just that you're given enough information. The question was, why don't they put the number of neutrons on there? Well, it's not that it isn't present. You're just given enough information to find neutrons. And how do you do that? The atomic mass, subtract the atomic number, gives you the number of neutrons. Okay, so this is where we left off with last time. And every time we go through a different element, atoms of different elements have different numbers of protons. So if we're saying element 21, that is what?
Scandium.
Scandium. If you're talking about element 82,
Lead.
it's lead, which is Pb. There's no L in there, but again, it's a Latin name. And Latin for lead is plumbum, and that's why it's called Pb.
Wait, are there some countries that speak Latin as their normal language?
No.
Why?
It's similar. I'm not saying that it's a dead language. I don't know where it would be spoken for sure. Maybe somewhere in the Middle East. Yes?
Can you move Tom? He's bothering me and distracting me.
What did I do?
You keep messing with me.
What if Don moves himself?
Okay, this is, all right. So as we move forward then, okay, We're going to spend a little bit of time on isotopes.
This way.
Okay? Yes.
Was that video over yesterday? Or are you going to finish that?
We're not going to finish it. We're going to move on. We're still not going to finish it today.
Okay.
All right? So what we mean by this, when it says carbon 12, okay, you might be illustrating and saying, I thought the atomic number identified these elements. Yes, it does. In both forms of these, whether it's carbon 12 or whether it's carbon 14, this one's got 6 neutrons, this one's got 8 neutrons. And again, that's what makes up the atomic mass of that element. And that's why you see it as carbon 12 and carbon 14, because one of them is radioactive, and that's what we're talking about here. This one is radioactive, where this carbon is stable.
So carbon 14's atomic number is 8.
No,
Okay.
What's radioactivity to us?
I was going to say the oxygen.
in high enough of forms. This carbon has 6 protons. This carbon has 6 protons. So, how many neutrons does this form of carbon have?
6.
And you're right. Why are you right?
12 minus 6.
Is 6. Okay? So how many neutrons does this carbon have?
7.
I think so. Just got.
So 6 from 14 gives you 8. So carbon 14 has 8 neutrons. Okay? Now, that can be true for any element. There's radioactive cobalt, there's radioactive uranium, there's radioactive chlorine. Okay? If you have the right type of lab setup, you can possibly create these isotopes by changing the number of the neutrons in there. Okay,
So carbon is an isotope because there's like multiple forms of them?
that's correct. And that's what this definition is saying. Elements of the atoms of the same element has different numbers of neutrons. This one's got 6, this one's got 8. The protons is still the same. Okay. I just want to get through this one because this individual might come up today in the video. Okay? Dmitriev Mendeleev. Mendeleev, I don't know for sure. There's probably 2 different ways that you can pronounce that. Okay? So this, with every increment of 1, you are changing the element because the protons are changing. Okay? So what is the best way to describe a period on the periodic table? Is it this direction or is it this direction?
Up and down. Wait, no, side to side.
Side to side. How did you change your mind? What led you to change your mind?
Well, I was thinking,
yes right
I was thinking, like the numbers go up and down, but they
Okay.
don't, you know what I mean?
Yep.
Back in my day.
Now, when you look at this, you might say, so what? Okay? Who cares how the first periodic table was arranged? And I would agree. But can you possibly give a time frame what you might think this first periodic table was arranged? Yes?
1975.
Too recent. Got to go older.
1842.
That's too old. I want to say maybe 1870s, 1880s, I believe. So the reason that is so significant is because when we look at even the first 18 elements on that table, okay, a lot of them, well, not a lot of them, but some of them are gases. How do you account for something that you can't see? Okay, and in this video, it'll explain how Mendeleev figured this out. Okay?
Mandela effect?
No.
Okay.
The Mandela's, oh, he didn't.
How about
Okay?
that? Thanks, Wes.
And the easiest way that I could describe that is this, okay? For, let's say, feeder cattle. Feeder cattle are about maybe $156 per hundredweight, okay? So if you have a steer that's 600 pounds, you're going to sell it and you're going to get $163 per 100 pounds. So you take that times 6, okay? But if something is twice as heavy, 1,200 pounds, you're going to get twice as much. So what had happened is the known weight of hydrogen would have been increased if it was 8 times.
How do they weigh the elements? Like, how do you weigh?
I'm not going to try to describe it. You're going to see that in the video if it makes it that far. That's what makes it complicated and this so astonishing and amazing that he could do that. Okay. So we're done note taking, but what I want you to think about, okay, who can numbers and letters? And I understand if you're viewing, I know there's a glare there and there's a glare over here. You just have to be able to work through it. Okay. Who can identify any of these elements? Which one?
The top middle one is hydrogen,
Why are you right?
because E is known as 1.
Okay, so it's got 1 electron. So how many protons? All these are neutral. So how many protons are in the nucleus?
1.
Just tell me. Yes.
The first one on the top, the blue one, is sodium.
Why are you right?
There's 11.
Okay. Okay. Just tell me.
The one on the top right is lithium.
Okay. Who? Just tell me. What's this one then?
Chlorine.
The red one is potassium.
Okay. All right. So all these are correct now. So now that we've identified these elements, do some of them have something in common with each other?
We all got 1.
They're all different colors. None of the colors repeat. But like, for instance, these two have something in common, and then these 4 have something in common.
What?
Oh, we have the
four
one.
have the E in.
Why is that important?
It's not.
It's not the end of a period.
There's only one, and this is one of your vocab terms too. Not only are these electrons, but these are called valence electrons, the ones in the outer energy level. These 7 are valence electrons. These 7 are also valence electrons. But where are these 4 located on the periodic table?
On the top left.
No.
First period.
You're close. You just used the wrong.
They're in the same column.
They're in the same column. So elements in the same column have similar properties. This is why they've got similar properties, because they've got 1 valence electron. So these are also going to have similar properties. So what column is chlorine and fluorine in?
3,
No.
7.
Okay. One thing that we will have to discuss later on is when we talk about valence electrons, it's just S and P blocks. So we do 2 and 6. We don't count these because these have multiple charges. So 2 columns, and how many columns are over here? Okay? So then, if we're looking at fluorine, it's in column 1, column 2, skip all the way over here, column 3, 4, 5, 6. Here's the 7th column. So what is 2 and 5 give you? 7. That's why the periodic table, should you know how to use it, what is that old adage? Knowledge is power? Okay? So then, is this in the same column as fluorine? So if it's in the same column, Why does it have a 2 and a 5? Because it's in the same column. That's going to be something that is very important for you moving forward. Okay, we went through that in a hurry. Is there any questions over this? Front row, are we on the bus?
Yes.
Second row, are we on the bus? Third row. If we are nodding our head yes, you're telling me that you understand this, and that's great. That means we can keep moving. Okay, so hunting the elements. We'll get it up to about where we left off, but as far as the video is concerned, we'll catch up to you next time.